Assalamu alaikum and hi. Back again with 1.4.4 volume of a solid of revolution. Through revolution of a curve by the x or y axis, solids like cylinder, cone, etc. can be produced as illustrated below. So as you can see from the first diagram here, there is a straight line. So when this straight line is rotated through the x-axis, it doesn't matter with direction, it will produce a solid in the shape of cylinder. And in the second diagram, we have a straight line here, and as we revolve the straight line through the y-axis, we will get a cone here. Okay, the same goes if it's revolved about the x-axis. We will still get a solid with the shape of a cone. So that's how a solid is produced by revolving a line or a curve through the x or the y-axis. Okay, so this is the formula for the solid produced by revolving a curve through the x-axis. Okay, so this is actually the formula for the volume. So when we want to find the volume, we have to express y squared in terms of x, and then we have pi here, so y is equal to fx. Okay, and then when we revolve a curve or a line through the y-axis, we have to express x squared in terms of y, and then the boundaries from C to D, where x is equal to gy. Now let's try example 12, question number 1. Find the volume of the solid of revolution formed by revolving the graph of fx equals 4 minus x squared about the x-axis in the first quadrant. Okay, so from the calculation, we have to find the value of x here, which is when y is equal to 0. So 4 minus x squared equals 0. So x squared is equal to 4, x is equal to plus minus 2. Okay, the negative 2 is on the left hand side. Alright, and then so now we have the boundaries, which is from 0 up to 2. And before we integrate, we need to express y squared in terms of x. We have that y is equal to 4 minus x squared. So y squared is equal to 4 minus x squared squared. Okay, that gives us 16 minus 8x squared plus x to the power of 4. So in order to find the volume, which is V, we need to integrate that, and then don't forget the pi, right? From 0 to 2, 16 minus 8x squared plus x to the power of 4 dx. So we get 16x minus 8x cubed over 3 plus x to the power of 5 over 5 from 0 to 2. And then 32 minus 64 over 3 plus 32 over 5 minus 0. And finally, the volume is equal to 256 over 15 pi unit cube. For question 2, you can try it on your own. and the answer is 2 pi unit cube. And now for question 3, find the volume of the solid obtained by rotating the region bounded by y equals x cubed, y equals 8, and x equals 0 about the y-axis. So for question 1 and question 2, we revolve around the x-axis. Now for question 3, we're going to revolve around the y-axis. Okay, so that is the diagram of the region that we want to revolve around the y-axis. So before we integrate from 0 to 8, the x cubed has to be expressed in x squared. So we want to find the expression of x squared in terms of y. So it is given that y is equal to x cubed. So x is equal to y to the power of 1 over 3, and therefore x squared is equal to y to the power of 2 over 3. Okay, so v is equal to pi times the integration from 0 to 8 of y to the power of 2 over 3 dy, and then integrate that, we get y to the power of 5 over 3 over 5 over 3 from 0 to 8, which is 3 over 5 y to the power of 5 over 3, and then plug in the values of the boundaries. We get 3 over 5 times 8 to the power of 5 over 3 minus 0. Sorry, I forgot the pi here. Okay, and here we also have pi on the outside, and then finally we get 96 over 5 pi unit cube as the volume of the region when it is rotated about the y-axis. Now let's try example 12, question number 4. There is a little bit of correction that needs to be made before we proceed with the question. So the question reads, find the volume of the solid generated by rotating the region bounded by the curve y equals cos x, x equals 0, and x is between 0 and pi over 2 about the x-axis. So this is how the graph looks like, and where the region that is going to be rotated is. Okay, so before we proceed, we need to express y squared in terms of x. So what we have now is y equals cos x, so y squared is equal to cos squared x. So what we have now is, if we want to find v, we have to integrate cos squared x dx from 0 up to pi over 2. However, it's not possible to integrate cos squared straight away. Therefore, we need to use the identity that involves cos squared x so that we can integrate the trigonometric function. So what we have is cos 2x is equal to 2 cos squared x minus 1. So finally we have cos squared x is equal to cos 2x plus 1 over 2. So now we're going to integrate this 1, okay, which is from 0 up to pi over 2 cos 2x plus 1 over 2 dx. So integrating that, we have 1 over 2 pi times sine over 2x, and then differentiate 2x, we get 2, and then plus x. The boundaries are from 0 up to pi over 2, and then substitute all the values. We get, on the outside we have 1 over 2 pi, and on the inside we get pi over 2 minus 0, which is equal to pi squared over 4 unit cube.